I just wanted to share some quick insights that I've learned about AI. I've been doing it for about 13, well, this is my 12th week, and I was aiming on doing it for 13 weeks, averaging 40 hours a week. And so I have one more week to go. And just wanted to share some quick insights. This is probably a one take video, so there might be random pauses and stuff in it, but I'll try to hurry and get to some cool points. So, the one of the key things is that almost all of the calculations that are done are dot products. And you can look up what dot products are, and they're basically multiplication and addition, but figuring out how to do it in certain orders. And anyway, that's a huge chunk of it. And the reason AI became so popular is because of graphics cards, because they do those computations, the multiplication and addition dot products, really, really fast. And it's an analogy is like a CPU on a computer. It's like, if I understood it right, it's like having a small number of people with doctorate degrees in mathematics. And they're doing, just picture people sitting at desk, like 8 people with doctorate degrees, and they're writing on paper doing mathematics with a pencil. But if you don't have to have complex mathematics and you have a huge number of calculations to do, like with AI, it makes sense to have something like 100 or maybe even 1,000 people at desk that are decent at mathematics, basic math, and that can go through with a pencil and paper and do basic math calculations like multiplication and addition. And so that's kind of what graphics cards do. And that's why AI has become popular around the same time that graphics cards started becoming real popular. So that's some of the key things. And things like ChatGPT, this is just kind of kind of random stuff, but ChatGPT, part of the way it works is it uses what's called next token prediction. You can think of tokens as sort of like words, and it'll take in whatever you ask it, and then it'll try to predict statistically based on training on the internet what the next word should be in that sequence. And then, if I understood it right, it takes all of that and then it says statistically what is the next word that comes after that. And then it'll take all of that again, all that you put plus the words it figured out, and predict what's the next word. And if you notice on things like ChatGPT, you'll see it doesn't just pop up with all the answer at once. It starts writing it out, and that's pretty much what it's doing, from my understanding. So, uh, and multivariable calculus is probably the most complex part, but in essence, it's if you really understand the derivatives, first principles, the f of x plus h minus f of x divided by h, then you can understand the multivariable calculus. And see what some other stuff. Some other key things are that the fully connected layers, like you may see in illustrations of AI neural networks, where you see dots and lines, connected dots, and then connecting over and over and over, just a series of dots, lines, dots, lines. Um, the whole point of AI training is to adjust those lines. Those lines are just representing numbers. So basically, the whole point of AI training is to adjust those numbers represented by lines. And then when you get those to be the right numbers, then you can put in data and it multiplies and adds and does some other calculations, but mostly multiplies and adds a whole bunch of them really fast to predict the correct answer. And so things like ChatGPT and self-driving cars, a lot of them, and pretty much anything to do with AI is based on that. They're called fully connected layers, because those dots are connected to each of the next layers of dots. Like all of these first dots connect to this top dot. Then all these first dots connect to the second one. And all these first ones connect to the third one, and so on. So they're fully connected. And if you notice things like for computer vision, there's things called convolutional neural networks. And you'll have typically they have something called translation invariance, which means if you have a picture of a cat on the left side of an image, or a cat's face on the left side of an image, if you don't have translation invariance and later you have a picture of the same cat but it's on the right side of an image, then it won't recognize it as well. But translation invariance, what it does is it'll look at features of the cat, like an edge of the ear and how it's linked to the next edge of an ear and the shape and the angle of it and so on, and the color and texture and all that stuff, and how this stuff's linked together. So whether it's on the left side or the right side of the picture, it doesn't make that much difference when you have translation invariance, and that's from convolutional neural networks, because basically it looks at little chunks at a time and pieces them together. It basically says, okay, this is a cat. It's over here, it's still a cat. So that's some stuff. That's convolutional neural networks. Transformers, like generative pre-trained transformer, if you notice the letters are GPT, and that's what chat GPT, that's what the GPT means, is generative pre-trained transformer. And a transformer is a architecture that was first came out in a paper in 2017 and called Attention is All You Need. And they go through things called there's the attention layer, and there's the fully connected layer, like I mentioned earlier, the dots, the lines connected to other dots, and so on. So it repetitively goes through the attention layer and the fully connected over and over. It does have a thing called normalization in there to squish the numbers down and so they don't get too big and so on. But that's a big chunk of what it's doing, is the attention layer and the fully connected layers, and doing that over and over. And so in neural networks, there are generally two types of things. One is classification and the other is regression. Classification is where you have different specific things like cat, dog, mouse, chicken, elephant, and so on. But or the numbers 0, 1, 2, 3, 4. But regression would be something like, just say, temperatures. Even though they're still numbers, they have a continuous, there's basically infinite of them in between each. Like, for example, if you say 1, 2, 3, those are called discrete. In other words, that's for the classification. Like I mentioned earlier. I think I mentioned it earlier. So you have like 1, 2, 3. Those are individual things. But regression would be like, in between a 1 and a 2, you can have an infinite number of numbers, like 1.01 or 1.93 or 1.27 or 1.48629, etc. And so that would be regression, and that would be continuous amounts, I guess you'd say. So anyway, there's classification and regression. Classification is saying, okay, there's a specific number of items that we're going to select from. But regression is like there's a continuous amount that it can go to infinite values, basically. So that's some other random things. And think of something else that's pretty cool and useful. In general, pretty much the brains of a neural network is those lines that I mentioned before and how they're connected. So somebody mentioned before that it's basically a CSV file is what the brains of AI is, or a comma separated value file. So brains of AI, you could think of as something like, you see a number 2.04, comma, 4.89, comma, negative 3.12, comma, and you just see billions or hundreds of billions or more of those, and that would be the brains of AI, basically. And they're called the weights, and they're represented by those lines that connect the dots. and the dots, lines, dots, lines. So the whole idea, or the main idea of training neural networks, is to adjust those lines, or specifically those numbers in the comma separated value file. Excuse me. And that's some random stuff about AI, and hope you find it useful, and hope it helps you on your journey. And so, in summary, AI is pretty useful. It can be extremely useful, and if it's done right. And the future, if things are done right, it seems like it can be really bright. So I know there's differing opinions on it, and just let me know what you think in the comments. And if you have any questions, let me know. And yeah, thanks for listening. Bye.